All right, in this video, we're going to go over again the constructor and deconstructor. We're going to go over the constructor and destructor now that we have kind of gone over some of the other stuff, like a little bit more about memory and a little bit more about the new and the delete keywords. So a constructor is a special member function that's used to set up the class. So we've kind of talked about this. I'm sure you kind of get the idea of it. It's automatically called when an object is created, and there are often more than one constructors available. The signature of the constructor, it's always based off the class name. So the name of the function is the same name as the class name. And then it can have arguments passed in as well. So the constructor for our vector, for example, it had a default constructor as well as a couple of other options as well. And so the default constructor had no arguments passed in. And then, you can see that there's other constructors that you can write, and they'll have, various parameters passed in to set up the class. The constructor is the place where you allocate memory. So you should always be declaring all of your stuff on the heap when you write the constructor. There's a couple of exceptions for this. If you are using in your implementation another container, like a vector or something like that, it gets kind of confusing, but that vector is declared on the heap, right? Because when it was written, it had this written inside of the implementation. And so if you're using another abstraction in the abstraction that you're writing, you might not have the new keyword, but for the most part, we're going to be writing our abstractions using the lowest level, which is like a C array, a linked list, a tree, or a graph, right? And so we will always be allocating the memory and handling it ourselves. But if you go back to the third video in this week, I showed you how to implement the random bag, which had a vector inside of it, and you didn't need to allocate memory in that case on the heap because the vector class was doing that for us. I don't know if that makes sense, but generally for our purposes, we will always be using the low level, pointers or C arrays in order to manage all of our memory ourselves, so we can really get an idea of how it works. So that's how the constructor works. It is allocating memory for whatever data structure that you're kind of managing. The destructor, on the other hand, is a special member function that's responsible for cleaning up any memory that you allocated. So it automatically gets called whenever the object's lifetime ends. So it's typically called automatically when the scope of its variable, when the variable goes out of scope. So when you leave a function or whatnot. The destructor uses the class name as well, but its signature is that it has this little tilde in front of it. And so for the destructor for our vectors class, this is what it looks like. And it's really pretty simple. In this case, the destructor is just going to call delete on the a C array that we've created. There's not really anything more to it in most cases. It's just like whatever was created needs to be destructed. You do have to be careful because if you have not yet allocated memory, for example, if you have a constructor that starts off at 0 or something like that, like has a size 0, you might have a empty data structure that maybe doesn't have memory allocated yet. And so you do want to be careful that you do not try to delete something that hasn't been created, because that will throw an error. So if you just check that A points to something before you destruct it, you'll be fine with that. So A not equal to null pointer is just saying that the A points to something and has already been allocated. You could also use other things to make sure that it's allocated, like check the size or something like that. So that's how a destructor works. So destructors need to call delete. If you are not allocating any memory, then you won't need a destructor. So like for example, in the case of the random bag, we didn't allocate any memory. All the memory is managed by other containers that we're using, so there's no need to have a destructor. So you can create a fixed size array at runtime using new, and then you're responsible for freeing any memory that you allocate by calling delete. So constructors are setting up the internal state of the class, and destructors are freeing any resources that that class allocates. And in some cases, you might be writing abstractions that don't allocate any memory on the heap, in which case your destructor wouldn't need to free anything. But the rule of thumb is anytime you call new, you got to call delete. You typically call new in the constructor, or as you can see with the rvector class, it also calls it a couple other times, like in the expansion in pushback. And then you'll want to make sure that you have a matching delete for each of those calls. So that typically happens in the destructor. So that's how constructors and destructors work in C++ classes. That's it.